Hello, everyone, and welcome to today's Hydromantis webinar. Today is the third part of our series about what are the new features and the new models that are available in the new version of GPSX, version 8.0. My name is Spencer Snolling. I'm VP of Product Development here at Hydromantis, and I'm happy that you could join us today. So as I mentioned, we've released this new version of the software. We put together these 3 webinars to be able to cover all of the new material that is in the software. And so we spent the first little while going through the details of the new interface features and the new models. And today we're going to be talking about how we've integrated Python with GPSX. So as you know, Python is a programming language that can be used to do a wide array of different things. And so we have now made it so that you can use that feature, integrate directly the information that's in our models and the actual software features themselves, and then integrate that with Python and do a lot of interesting customization. So the plan for today is that I'm going to have a few slides just talking about updating your version of GPSX to version 8.0. I'll talk, sort of introduce the concept of how this works, how we integrated these 2 pieces of software together. I'll talk about the Python versions that we're using, how you go about installing packages, and talk about the tools that are in GPSX now, including our Python scripting manager that basically allows you to control and run those Python scripts and have them interact with GPSX appropriately. And as always, I'm going to run a couple of desktop demonstrations so that you can see a couple of these things in actions. My plan for today is that I'm going to do, or just run through and demonstrate a couple of the tutorials that we have created around Python. And as usual at the end, I will identify a couple of new things that are coming along, talk about the webinars that are coming up. And as always, I'll answer the questions that might come up for you while we're going through the presentation today. So you can find our question window in your GoToWebinar dashboard, and I'll ask you to type any questions that you might have along the way in the box, and I'll see those come up here on my screen. And excuse me, we can answer those when we get to the end of today's webinar. Okay, so first of all, version 8 is now been shipped to all users. So basically anybody who has a yearly subscription of GPSX, excuse me, or an active technical support contract should have already received their updates automatically. So you will have received an email with a document that was attached and had some instructions on how to come and load the software, and any changes that you might have to make to your key codes, for example. Excuse me. If you are not sure if you qualify for an automatic upgrade to the new version, or if you had been expecting to receive it and you have not heard from us yet, please email us at info@hydromantis.com. That will come to our group here that handles all of the licensing and so on, and they will make sure that you've got the version of the software that you were expecting to get. Okay, I'll just touch very briefly on the new things that are in the software that we're not going into detail today. So I've covered these previously in the last couple of webinars, but it's good for those of you who might not have been part of those. We have 3 new model libraries. So we now have activated sludge models that include selenium and sulfur compounds. We have a process water treatment library as well. So for doing water treatment, drinking water, processed water that's used in industry, for example. And we have an industrial version of GPSX now, the petrochemical wastewater library. So for doing petrochemical refinery wastewater treatment, for example. We have a large number of new unit process objects. There's 13 of them in there, and you'll find those in the unit process menu on the left-hand side of your screen. And then also we have new drawing board features, new data handling and validation tools, some new data visualization things. So I have gone through all of that in quite a bit of detail over the last 2 webinars. So if you didn't have a chance to find out about all those details, what I recommend is you go to our YouTube channel, youtube.com/hydromantis. And if you look in the newly uploaded videos, you'll see that the 2 most recent ones are parts 1 and 2 of our What's New in GPSX version 8, and you can view those in their entirety there. And today is version 3, and that today's webinar will be up there soon as well. Okay, on to talking about how you can use GPSX and Python together. So now, since you're here and registered and attending today's webinar, I'm going to assume that you probably already know about what Python is and how it works, how to do coding, and so on. So I'll be just using a lot of terminology, Python terminology, that without going into details about those. So basically, this Python add-on, this Python module that allows you to combine GPSX and Python is part of our GPSX Pro Plus license. So you need to have that part of your license activated in order to get access to what I'm going to be showing you today. And if you don't know which license you have, you can always email us at info@hydromantis.com to get that detail. And all of the scripts that you will be creating are run from within GPSX in our Python script manager. But you can actually use external Python tools, such as Python specific editors like Spider, which is the one that I happen to quite like, to do the editing of the actual code, that actual file, .py file. Sometimes you may find that those are really handy. When I'm going through today's example, I'm just using Notepad++ because it tends to be the one that is sort of easy to see and work with. So, but you're welcome to use those other ones, but you won't be running the script from there. You'll be running it from within GPSX. So when you install version 8 of GPSX, you will get Python installed automatically with it. We're installing both versions 2.7 and 3.7 that will get installed along the way. It is possible to use other Python versions, and we have quite a lot of detail about that in the GPSX User's Guide. And you can configure other versions of Python that you might already have installed on your computer, for example, and it will use those ones. But by default, when you install the software the first time, it comes with its own version of Python. So when it comes to the point that you want to take advantage of all those excellent packages that are available out there in the world, you do that via pretty much the same way that you would do that in your own regular installation of Python. You would open a command window and navigate your way to this folder here, GPSX 8.0/Python, depending on which version you were using. And then you can use tools like pip to do the install of the packages just as you would normally. So. And then GPSX will be able to access those packages and when it's doing the interpreting, use all that good stuff. So the best way to think about this is that this is now kind of a wraparound for GPSX. So you'll have your Python code that you will be writing, and it can directly interact with GPSX by setting values. You can send information to the GPSX model and to the interface itself. You can interact with the model while it is running, and then you can collect any other information that you like and send it back to your Python script. And that can be done before, during, or after the simulation. And then on top of all of that, you can control the simulation itself by starting and stopping and doing whatever you want programmatically. And so this is actually quite a step forward and an advanced tool as far as GPSX is concerned. We haven't been able to have another tool that can do that, where it can work completely externally outside of GPSX and can do calculations and remember from one simulation to the next, and use that as a way to sort of ultimately do a large amount of interesting simulation with the software. Another way to look at this is that really you're using GPSX as an object within that Python script. So you'll find that we have these various functions developed for you where you can use them, such as this one here, where that object has a method built in to get a value. And you're using the cryptic variable name out of GPSX here to be able to use that method to get it and assign it to this variable that you may have. And we are doing that for both the regular scalar variables and the vector variables and so on. We have methods to handle all of that. There are, in fact, 25 predefined functions relating to GPSX operation that allow you to do things like start, pause, and continue the simulations to reset all of the values. You can set parameter values, so input into the GPSX model. You can retrieve the results back into your Python script. And as far as the interface goes, you can actually activate parts of the interface from the Python script itself. So you can use the GPSX scenarios. If you've already got that all defined, you can go down there and select which ones that you want to use for a given simulation. You can activate other GPSX tools that are there, like the analyzer and the optimizer, for example. And you can generate the reports that we create in GPSX programmatically from Python. So that allows you a really powerful tool to be able to sort of automate some of those processes. If you have very long simulations that you need to run and you want to kind of do them as a batch, you can now set up a Python script to do that. So it is a fully native Python installation. It has access to all the Python packages out there in the world that you can use. And so we've been experimenting with these and using these as part of our development here recently. So you can have things. I've got some examples of some of these packages here. NumPy for statistics. There's data visualization tools. There's some really fantastic ones out there. I will be showing you using Matplotlib here shortly. Data science tools, Pandas is of course the main tool there, the main package that you might want to use there. Process control, so PID and other even more advanced tools that you can use in that sort of communication interval. Every time that the simulation is running, you can have your process controller from Python interact with the model. Database access, you can build Python scripts that will handle sending data to and from GPSX and also to and from MySQL database. And essentially anything else that you could possibly think of. I've slowly been learning and sort of expanding my knowledge of what's available out there in the world in terms of those Python packages, and it's really very impressive and amazing what you can find out there to do the things that you might want to do. So anyway, the doors are open now, and we got lots of opportunities. So one thing that we've been seeing as a couple of examples of things that you could do is, as I mentioned, if you wanted to sort of make a batch simulation of GPSX where you have a bunch of scenarios and you would like to just run them all one after another, and then you want to generate a report in between each one, that's obviously something that you can do now. You can use whatever advanced techniques in Python that are there for generating input for your simulations. So for example, we did some experimentation here just recently with using, for Monte Carlo simulations, using a package to do Latin hypercube sampling for us and generate all of those values of input parameters that for each one of the runs of our analysis, for example. You could perform advanced data cleaning and data reconciliation using some of those tools that you can find out there to clean out outliers and all of that. Those kinds of tools already exist in Python, and you could use those to clean your data before sending it in for the simulation. And as I mentioned, I know there's interest out there in using the wastewater process control packages out there, and you could develop and test those things and try them out on your wastewater treatment models. Okay, so the way that it works is that we have a new thing called the Python Script Manager. It's available in the Tools menu, and it is based sort of set up so that you can have multiple scripts that you would have created for any one particular layout that you have. So now the Python's work that you're going to do is going to be using the cryptic variable names of the things in GPSX. So, your effluent, ammonia, and so on is going to have a specific cryptic variable name. So when you save these Python files, they're going to be specific to this particular layout. So there are those files that are associated with this particular layout. You'll see starting and stopping for being able to run and interrupt your Python script. A few other buttons to handle resetting variables and doing a few other things related to the way that Python interacts with your system. And obviously an output console. So when you do print in Python, it will come out to this console. Now, if you are using this to create and set some variables in GPSX that also happen to be on a slider, you'll see that the slider itself will respond to the changes that are being made by Python. So if you make changes to that parameter, you'll see the little knob moving around on its own. And same thing for all of the other features in the software. If you are selecting a scenario, you'll be able to immediately see that scenario change, and you'll see that it's being selected from the menu accordingly. Okay, so let's first of all take a look at a simple desktop example that we've got set up here. And this is actually tutorial 15, so you can play around with this on your own. This is a conventional activated sludge plant here, and it's got a regular influent, wastewater coming in. And we've also got this other thing here, the rainwater influent. And I'll just highlight very briefly that this is also something new in version 8 of GPSX. This is our runoff model. And so basically this is clean water, and it will come in at a flow rate of 0 until you specify some rainfall happening. And then based on the characteristics of that watershed, it will bring some flow in for a period of time. And so what we're doing in this example is we are going to run a Python script that will provide randomly generated rain events to this to this rainwater influent object. So I'm going to go to the Tools menu here. I'm going to go to Python Script Manager. I'm going to bring up this menu, and we can see here for this particular tutorial that we've got 3 of them here, and I'm going to grab that first one. And I'm going to go into a lot of detail later on, but I just want to show you what that Python script looks like. You can see here, this is starting from a template that we will give you about how to set these things up. But just to give you a bit of a flavor before we get into the details, we're setting some parameters, and then we're calling in the communication interval here this bit of code. And you can see here it generates a random number between 1 and 100, and then based on that probability, it assigns a certain value of rainfall based on this particular list of values up here, and then it generates it again, sets that back to 0. And so essentially what's going on is that the GPSX model will receive for this particular cryptic variable values from Python while this is running, and those values are going to be randomly generated. Okay, so all I do basically is hit start. So while this is running, I can take a look here. So this is 2,000 meters cubed per day of regular wastewater influent, and there's our first rain event. It's one of the big ones, and then we can see here, and now a second one has happened, and this rainfall runoff model basically is something that kind of creates a peak, and then there's a decay back to 0 again. And so we've got different sized events happening here. And all of these are being randomly generated. Every time I run this, I would get different results. When I was practicing my webinar earlier this morning, I ran it once and there were no rain events at all. So I'm glad to see we got at least a few. And just for fun, I also printed out a little log of all of the rain events that happened. So we got one large event there at 4 days and another one at 8. And then we got an extra large rain event at 20 days there. And the definition of all of those, of course, is in that file. Our extra large rain event was right there. Okay, so those are all nice and sort of straightforward way to describe how to get and how to set the parameters that would be used in a model in an interesting kind of way. Right, okay, so let me go back to my slides so I can see. And we'll talk a little bit more about those methodologies. So I'll say very briefly out the top here, there is quite a long detailed section in our GPSX user's guide, how to do all of this. And then we have a bunch of new tutorials that will take you through the development and how to learn how to set these things up. But I'll just mention them all pretty briefly right here. So basically, when you start and create a new Python file, it'll be a .py file that is the same name as your GPSX layout, and it will fill with this regular template here that has definitions of various functions and a call basically to run the simulation, and then you can edit from there as you like. So the start function is executed once at the start of the simulation. So for example, things you might do here would be to select a particular scenario that you've already got predefined in your GPSX layout. You may want to set one or more values. So in this case, you might want to set the temperature to 10 degrees Celsius, and I might want to set up and declare some variables. This is a list variable type in Python. And right now it's blank, but it's going to be ready so that I can append and add some information to it. The cint function is basically something that is executed every communication interval during the run. So during the communication interval, I can replace that function with other things that I might want to do. I might want to get a value from the model, this value here, and I might want to add that to my list that I had, and might want to do other actions. Maybe I want to set some other variables based on calculations that I'm doing. The EOR is end of run function, so it's executed once at the end of the simulation. And in that case, typical thing you might want to do is once the simulation is finished, I want to generate a report. So you'll get a report just like the typical ones you get out of GPSX. So the actual function that runs and controls the simulation itself actually can be used inside other Python code. So it's free-form coding. You can sort of do it whatever way you like. You might want to say, I want to run the simulation 10 times. And each time I'm doing it in that start section, I'm going to make some calculations and set some variables and do whatever it is I want to do. So there's lots of opportunity for you to be able to use these types of structures to control GPSX in a way to get it to run numbers of simulations, change that input, and collect the output as needed. So as I mentioned, there's about 25 of these pre-developed functions that are available for you to interact with the interface itself or to get values and set values in the software. And so those are all available in the GPSX User's Guide. Okay, so let's take another look at a second one that is looking at doing sensitivity analysis. So I was only running one simulation here. I'm going to take a look at one now where I can do simulations, multiple runs, one after another. So this is again a regular conventional activated sludge plant. And in this case, I'm going to do sensitivity on temperature. So just let me move that out of the way for a minute here. You can see we're setting the liquid temperature at that plant. And so we're going to run a number of simulations. And we're going to adjust that, and then we're going to plot some things at the end. So let's take a look at that code that we're using here. So here's the .py file. We're declaring these variables here, the number of sort of settings that we want for the temperature from the low value to the high value. And down here, if I slide down farther, you can see that we're actually doing this now in a loop here in this range. For different temperature levels. And in each temperature level, we are executing this GPSX function, which is defined up here, that basically selects a given scenario. It sets the t-stop value, it sets the value of the temperature, and then it runs the simulation. And it does it for 3 different scenarios. So this is actually running a regular type of linear sensitivity analysis, except we're doing it on multiple scenarios at the same time, which is a feature you can't have or you can't do in regular GPSX, but this is going to step through doing all of that. So it's going to run simulations while it's changing parameters and while it's changing scenarios. And it's collecting all of that output. In this case, we're just looking at what is the effluent ammonia. And then the last step in the process is to use matplotlib to develop and plot all of that information separately and create outside of GPSX a graph of those results. Right, okay, so let's run that simulation here. So first of all, you can see the value here of the temperature will move along every 3 simulations. And down here in the lower left-hand corner, you can see that it's switching between the different scenarios of the base model, the low value, the high value, low flow and high flow. And as it steps through, and it's going to do each of those 3 scenarios for all of the temperature settings that we have. So that will be almost done here. And then once that is finished, it is going to go through and generate via Matplotlib the image that is the results. So there you go right there. This is now a PNG file that it created and opened for us via that script, that Python script. So we were using matplotlib and I believe one other package here to do some, use some of the Python image library graphics that were available. So, but as I mentioned before, you can use whatever package you like. They'll all work within the system that we have. Okay, so let me go back to my slides to wind things up here. So one thing that is a really big change, and I find this to be really great, is that now in Python, most of these GPSX functions that we have created also include the ability to convert between units. So if you have done customization in the past in Axle, you will know that you have to set everything in our standard SI units because Axle is using SI and all of our calculations are done in SI. However, in Python, you now have the option to work in whatever units you like. So in our things such as get value, you can specify, I want you to get a particular value of a parameter in GPSX, and I want you to get it in a specific unit for me. And then once you've retrieved it into your Python environment, then you can work in whatever units you like. I've been actually enjoying working with the Python package Pint, which allows you to work very nicely in lots of different units, and it automatically calculates the unit corrections and unit conversions for you. And Pint is really cool. So now you can actually work back and forth within GPSX in whatever units you like. Java classes are also supported within our Python implementation as well. That's a whole other separate webinar probably. But basically, check out tutorial 17. It shows you how you can use some Java graphics classes to be able to create other additional types of graphs and outputs and things that you might want to run interactively with GPSX. So it actually helps make a clock for you, and you can see that as a demonstration. And then the Python customization is still able to be used directly alongside any existing custom Axle code that you will have already made. So we're still continuing to support Axle. And the only thing is, of course, Axle must be done in SI units when you're doing your calculations. So just winding things up and concluding, this is a really significant upgrade for us to be able to do this kind of model customization. We're very excited to be able to bring this to you. We want to learn about all the cool things that you're going to build. It takes advantage of all those existing and ever continuing to be developed Python packages, open source packages that are out there in the world. You can build your own library of simulation-based tools for doing complex analysis and optimization and visualization of the results from the model. And we've created 5 new tutorial exercises to teach you how to use the system. And those are all available in the File Sample Layouts Tutorials menu. So just let me just very quickly show you that. So I'm going to move that out of the way. Files, Sample Layouts. And as you probably know, here we have about 60 or 70, actually I think it's more than that now with version 8. Various types of layouts that are already built for you. These get installed when you install GPSX. So if I go to the tutorials menu, we used to have 11 tutorials. We've expanded it quite a bit now that we've added a lot more new features to the software. So you'll see that there are now actually 17. But the last few here from 14 through 18 are ones that use Python. And if you do those first few ones there, controllers and sensitivity analysis and so on, you'll get the feeling for how to use that. Okay,